Alright, good morning everyone. Okay, so today we will be covering chapter 11 as requested. Alright, now I want you to open the slides for chapter 11. Okay, so let's have a look at the slides. Alright, so chapter 11 is basically about special probability distributions. But for today, we will be only covering one of the subtopics, which is the normal distribution. Okay, so if you have a look at this, okay, these are the learning outcomes. They are discrete distributions and also continuous distribution. Okay, but we will focus on the continuous distribution. We will not focus on discrete distribution. Okay, so we will go straight to normal distribution. Okay, normal distribution is one of the continuous probability distribution. Okay, if you can recall back, continuous distribution is related to things or variables that can be measured. For example, height or weight or what else? Things that can be measured. It can be measured in a ruler. Okay. Okay. It is the most useful distribution. And there are a few characteristics of normal distribution. Number one, it is unimodal. What does that mean? It means that there's only one mode. Okay? There's only one mode for the distribution. There can never be two modes or three modes. Modes value, model value. Model value is the value that happens the most frequent things, the most frequent measurement. Okay, it is symmetrical. What is symmetrical? Symmetrical is something that if you fold the paper, it will be the same thing. It looks the same. That is called symmetrical. And measures of tendency are identical, and it is asymptotic to the x-axis. Its height and spread depends on the variation. Okay, we will have a look at this. These are the few characteristics of normal distribution. Okay, this is the explanation of it. There's only one peak at a single value. It's unimodal, symmetrical. Okay, 2 points equidistant. It means it has the same distance on either side of the mean. It's the mirror image of the other side. And for normal distribution, the mean value, the median, and also the mode would be equal. Alright? Asymptotic to the x-axis, it means that it will approach the horizontal axis on either side of the mean towards plus and minus infinity. We will have a look at that later on. Okay? Okay, you will be able to know that the height and the spread depends on the variation of the distribution. Okay, this is the formula. Okay, don't worry about this formula. When you use the normal distribution table, you don't have to use this formula because it's already calculated for you. Okay, so you just have to know this formula. Okay, now the first step for you to to evaluate or calculate a normal distribution, you need to be able to have the value of the mean or the value of the variance. So when you want to find the fx for the values below, so basically you just substitute the formula, you just substitute the mean and variance into the formula, okay, and then you will be able to get the value, okay. But this question is not that common, because this is just finding the fx. Usually we want to find the probability, okay. Okay, so this is just examples of substituting the mean and the variance, okay. Okay, the first step to find the probability of a normal distribution, you need to convert it into a z. Okay, now this is very important because you need to use this formula to calculate the z value, okay. Now, for example, if you are given the mean of 2.5 and the variance of 4.7, okay, let's make this smaller. Okay, so let's have a look at this. Okay, the formula for z is z equals to x minus mu over standard deviation. Okay, now this x is what you are measuring. You will be given this x, and the mu is equals to 2.5, and the standard deviation would be the square root of 4.7. So in this case, mu is equals to 2.5, and standard deviation equals to square root of 4.7. So approximately equivalent to 2.1679. Okay. Okay. So to standardize the values below, okay, given the value of x, what you need to do is you just substitute your x inside this formula. So this would be 5.3 minus your mean value, which is 2.5, divided with your standard deviation. So you will be getting 1.2915. And the same goes with question B, for example, 7.1. You want to standardize the value, you substitute inside minus your mean, which is 2.5, divided with your standard deviation. You will get your z value. This is called the z value. And for question C, 1.2 minus 2.5 divided with your standard deviation, then you will get your value. And finally, for question D, x equals to 9.6, you will get your value here. Alright. Okay, so this is calculating the z value or standardizing the values. Okay, now the second thing that you need to know after standardizing the value is to draw, not draw, it's like sketching roughly your normal distribution. Okay, this is your normal distribution. It has all the characteristics that is being listed out in our previous slide. Okay, it is unimodal. It has only one mode. It is symmetrical, meaning that if you cut this into half, it will be the same thing, left hand side and right hand side, both sides. It is asymptotic to the x-axis. Why? Because this is approaching your x-axis. This is your x-axis here. Okay. So for a standard normal table, your mean value would be equals to 0. Okay. Now, to look at your standard table is by looking at your graph. It's looking at your graph. This is your x-axis. So if z equals to 1.2915, if this is your x-axis or this is your ruler, this is 0. So 1.2915 would be here. So z greater than 1.295, it will be the area here. Okay, now before that, let's convert our previous example. Oh, sorry, there's no previous example here. Okay, anyway, let me show you a few more examples here. Okay. Okay, now let's say that you want to draw or sketch the distribution of z less than 1.23. Okay, so you draw your normal distribution, and this is your values of your this is your axis, your x-axis, and this would be 0. Okay, z being equals to 0. So 1.23. So if you see this as a ruler, so 1.23 will be somewhere here. So z less than 1.23, it means that you are interested to know the area here. Okay, so if p z less than 1.23, so if this is your 0, 1.23 will be somewhere here, the same as this one. But this time, oh sorry, if I change this to greater than, it's greater than, so it would be this area here. Okay, so other examples. Okay, let's say let's change this. Let's drop this off. Okay, let's say that we would like a negative value, negative 0.